Okay, we are done with the combination circuit design, and before we move to the sequential circuits, there are some questions. This will be an assignment for you. When we are having physical classes, I had given you 2 questions as an assignment. I told you that you will keep on solving these problems and then finally you will submit it by the end of the semester. Right? So again, I will give you some questions. First, you will try to implement the function f a b c d with the min term 0 1 3 4 6 8 10 11 12 and 15, and you will try it using a single 8x1 multiplexer, then try it using two 8x1 multiplexers and single 2x1 multiplexers. Then try it also using 5 4x1 multiplexers. A hint: first one, this one actually is a one down implementation wherein you have to create a table the way I have taught you. This one is a straightforward implementation. Only thing is that instead of using a single 16:1 multiplexer, you'll have to use two 8x1 and then combine their outputs using a 2x1 multiplexer. Similarly, this one is a straightforward implementation. Again, instead of using a single 16, you will have to use 5 4x1 multiplexers. First level, you will have 4 4x1 multiplexers. Then their outputs you will combine using a 4x1 multiplexer. Like I said, when you use multiplexers, when you decompose higher order multiplexers to lower order multiplexers, the main thing you have to look for is the order in which you actually use these variables in the section line. I have taught that. You can also consult the videos, and this will be one of the questions for your assignment. Then another question that you will try is you will implement a 4-bit binary to gray code encoder using an appropriate mux multiplexer. Fine. We have done this. We have done this using gates. So here you will have 4 inputs, which means you can either go for 16x1 multiplexer, and you will have 4 outputs. So for every output, you will have a separate multiplexer. Remember, multiplexer only has one output, right? So you can only implement one function using a single multiplexer. Since there are 4 outputs, we'll have to use 4 multiplexers. So straightforward implementation will be 4 16x1 multiplexers, one for each of the gray outputs. And you can also try one down implementation, wherein you can construct the table and implement using 4 8x1 multiplexers. So you should try it using 16x1 multiplexers. That's for every output, and then try it using 8x1 multiplexer. Right, so this is question number 2. Then you will also try the reverse. You will try to implement a 4-bit gray to binary encoder, again using 16x1 mux and 8x1 mux. So this is 3 questions for the multiplexers. Fine. We have done a couple 3 to 4 lectures on this. I hope you will be able to actually implement it. Then final question, question number 4. Yeah, just leave it. 3 is sufficient. So 2 questions I gave you in the class, 3 more here. So a total of 5 questions up to this point. So as a record, I'll keep here total of 5. I will keep adding. I'll keep adding to this tally as of 16 May. Yeah, it's 15 actually. So like I said, I'll keep adding more questions as we move towards the sequential circuit. But as far as combination circuit goes, this is it. Next video, we'll be starting sequential circuits.